Look down at this stretch of no man's land and you'll see a moonscape of overlapping craters. But flying quietly above it is a dark speck carrying a terrifying payload, a heavy 50-kilo shape charge swinging wildly on a cable, right beneath the belly of a cargo drone. This flying pickup truck is a Malloy T-150. The Australian cattle ranchers who originally designed it to haul supplies across the outback definitely didn't envision someone strapping a bomb to it. But with a 68-kilo payload capacity and whisper-quiet electric motors, it's perfectly suited for war. Its target is a bridge on the far side of a river crossing, and this specific bridge has already survived months of direct hits from American HIMARS rocket artillery, a system firing 90-kilo warheads that usually erase supply depots with ease. The problem is physics. Bridges are built specifically to take extreme punishment from above. Dropping rockets on the flat upper road deck is like stomping on a heavy table. You might dent the surface or punch a hole through, but the thick vertical columns underneath simply shrug off that downward force. To actually bring this bridge down, the drone pilot has to thread a needle. He needs to fly perfectly over a pre-existing crater in the road deck and carefully lower his swinging explosive down the hole so it rests directly against one of those hidden vertical columns. But the 4 kilometers of empty air between the pilot's trench and that bridge is filled with a dense, invisible web of electronic warfare. The moment this drone leaves the ground, a deadly cat-and-mouse game begins. The Ukrainians open with a barrage. 6 fast, cheap, first-person view suicide drones scream across the river ahead of the heavy cargo lifter. The goal is suppression. Force the Russian soldiers to stay pinned in their dugouts so nobody looks up and spots the slow-moving bomber. To make sure the path is clear, the Ukrainian crew watches a Chuika 3.0. It's a specialized detector that intercepts the live analog video feeds from Russian drones. It acts like a hacked security camera, letting the Ukrainians see exactly what the enemy pilots are seeing in real time. Right now, their screen is clean. But across the river, a Russian electronic warfare operator is completely ignoring the explosive barrage hitting his trench line. He's watching a totally different piece of hardware, the Skypoint 2. The Skypoint 2 doesn't use active radar. It relies on passive radio frequency listening. Every time the Ukrainian pilot moves his control stick, the system hears the radio signal. By crossing the directional bearings from 2 separate receiver units, it acts like caller ID, pinpointing the exact coordinates of the pilot's controller. Because the system operates passively, it doesn't transmit a single watt, leaving the Ukrainian screens completely blank. The Ukrainian crew is hunting a target, entirely unaware that the enemy has already geolocated their exact position. High above the river, the cargo drone reaches the crossing. Suddenly, the pilot's video feed fractures into pixelated static. The controls completely lock up. Now, a heavy drone carrying 50 kilos of live explosives is drifting blindly on the wind. The drone flew directly into the range of a Russian SER VSS5 jammer. This system ignores satellite navigation entirely. Instead, it targets the radio control link, the vital connection between the pilot's hands and the drone's motors. It works by flooding the frequency with a massive wall of noise, like blasting an air horn into someone's ear. To regain control, the pilot manually cranks up his transmitter power, forcing a stronger signal through the jamming wall. He pushes the power to maximum. The video feed stutters back to life, saving the multi-million-dollar mission. But that massive signal spike just gave the Russian Skypoint 2 a crystal-clear lock on the pilot's exposed trench. The cargo drone arrives over the bridge crater, only to immediately take heavy machine gun fire from a concealed sandbag position on the far bank. Back in the dugout, the pilot's hacked Chuika screen erupts in warning. Multiple Russian suicide drones are suddenly inbound, moving fast across the river and heading straight for his exact coordinates. The operators abandon their controls and sprint into the exposed communication trench. Seconds later, a massive, high-pitched blast obliterates the bunker they just evacuated. Those incoming suicide drones were just a distraction. The real weapon was a Lancet 3 loitering munition. Armed with a tank-busting warhead and an X-shaped wingspan, it had been silently circling far above them for minutes, patiently waiting for the crew to break cover. It is a brutal execution of combined arms logic. The cheap, noisy suicide drones acted as the dogs, used to flush out the human operators. The Lancet was the shotgun, waiting for the birds to fly. The operators survive the blast. Shielded by friendly mortar fire, the pilot manages to re-establish the connection. Hands shaking, he painstakingly lowers the heavy charge down through the bridge crater until it rests directly against the concrete support pier. But out of dozens of identical support columns holding that span up, how did the Ukrainian engineers know the centimeter-perfect geometry required to build a custom charge for that specific column? They got the blueprint from a Russian soldier. Months earlier, he posed for a smiling selfie right under the bridge and posted it to Instagram. He inadvertently framed the exact structural dimensions of the columns, allowing engineers to screenshot the photo and measure the geometry perfectly. The pilot hits the detonator. The blast drives a superheated jet of metal into the pier, instantly vaporizing the concrete. With its support completely severed, the indestructible upper road deck finally sags and collapses. This is the reality of modern asymmetric warfare. Heavy, multi-million-dollar military systems are being routinely defeated by off-the-shelf detectors, $400 drones, and the deadly consequences of a single careless digital footprint.